So we're going to solve for t. We're going to deal with this formula again in the next set of notes, seeing where it came from. But basically, n is how many times per year you actually calculate the interest. T is the number of years. So if we're solving for t, let's see, t is stuck in the exponent. We need to get rid of things from the outside in. We'll get rid of what's furthest away on the same side as p. So
ST.
divide both sides by p first. Now we just have an exponent. Okay, so how do we get rid of an exponent? Remember that c equals a to the b means log base of the exponent is the base of the log of go across the equal sign. So it tells you the exponent. So if I turn this back into exponent, into log form, it's log with that wonderful base. Go across the equal sign. Okay, so finishing solving for t, instead of dividing by n, I'm going to multiply by 1 over n. It just makes it easier to type into the calculator and prettier. So, little note, I suppose. Special. All right, so let's use the actual thing. I start with $1,000. Interest rate is 6%. So notice that 6% is 6 divided by 100. Which is 0.06. Make sure you turn it into a decimal. Quarterly means 4 times per year. Every 3 months. So n is 4. And t is 8 years. So stuffing everything in. We get $1,610.32. So just a special note. Older calculators, if your calculator doesn't automatically make small numbers when you hit the exponent button, you'll have an order of operations problem. Okay, so let's see. Next, $2,000. How long does it take to double my money? Let's see. This time I don't know t. So I'll use that formula that I just got. Notice that one thing that it might be easier to do is just turn a over p into 2 immediately. So we have 1 over n times log base, silly base, A over B was just 2. How do you type this in? Change of base formula. Log of the number divided by log of the base. Okay, so
oops.
Okay, and calculator says 11.63 years. All right, another application that comes up a fair amount is what's called radioactive decay. Radiation is when an atom spits out usually an alpha particle, which is essentially a helium atom that takes out 2 neutrons and 2 protons. And that's the fact that it loses protons means that it's going to change into a different element, and so it decays into something else. Regardless, half-life means how much time does it take to have half of the original amount. So for our purposes, we just put in half of P for the amount that we currently have. Don't mess with the original amount. The fact that it's e to the kt, and as opposed to some random base to the nt, not really a coincidence. Let me just write down that k is a decay constant, rate of decay. You have exponential growth if your rate of change constant is positive, and you have a rate of decay if your rate of change constant is negative. Remember, ln1 is 0, ln of 0.5 is negative. Okay, first thing we do in actually doing this, we cancel the p's, and then we're left with, I have a number for t here, 5,700 years-ish. Okay, so I un-e by lning the left side. So my rate of change constant is ln of 1/2 over 5,700. So to use that, for instance, 12% left means that the amount that I currently have is 12% of the original instead of half. Try and make your e look a little large or your exponent look a little small. Make it not look like multiplication. Okay, we un-e again.
Remember, this is k, because it's kt.
And get rid of a fraction by flipping it. So So it takes about 17,500-ish years. Can't spell today.